Hi, this is Naufal from Note Solution. We're going to be talking about indifference curves today, and we're going to be examining an easy question just to clarify our concepts. So the question says, except for perfect substitutes or perfect complements, an indifference curve has a slope or has a dash slope and becomes dash or blank moving to the right. So first of all, let's just see what sort of a slope an indifference curve usually has. And so you're usually accustomed to seeing this sort of indifference curve, which is bowed inward, and you usually have the equilibrium because of the budget constraint over there, which is usually in the middle. So what we're here to examine is, first of all, why is this going to be sloping downwards or sloping upwards as we move right? And if the indifference curve has a slope that's negative or positive. So let's come to the first one. So as you can see, I've drawn some lines over here, just tangent to the indifference curve. And first of all, you can see that they are downward sloping, like your demand curve in previous lectures. And so, as we all know, a demand curve or a downward sloping line has a negative slope. And so one of our problems have been solved. So the slope of an indifference curve that is bowed inwards, or is a regular one, is negative. And the next one that we want to know is if it's getting steeper or flatter. And that we can tell, as we've seen, moving to the right, so moving in this particular direction, or in the direction of more consumption of good X and less of good Y. You can see that this line is getting progressively flatter. It started off as very steep, and towards the end, or towards a higher consumption of good X, has become really flat. And so these are the two things that we wanted to know about indifference curves. First of all, it was convex or bowed inwards towards the origin. And the second thing, it has a negative slope, and it becomes flatter, which becomes flatter and flatter as we increase the consumption of good X. So this question also said except for perfect substitutes or perfect complements. So let's examine what sort of indifference curves those goods have. And so perfect substitutes, as we all know, something like Pepsi or Coca-Cola, and so you're only going to be consuming one or the other of those two goods. And that's why you can see there's a flat line or a straight line when it comes to the indifference curve. Yes, this is actually an indifference curve for substitute goods. What this means is that you're either going to be consuming only Y, so somewhere over there, or you're going to be consuming only X, just because they're perfect substitutes or perfectly substitutable for each other. So that means that they are basically, their slope is constant throughout, as is the case with a straight line, and they are substituted according to that particular slope. So, for example, if the price of X were to increase, you would consistently consume only Y because that's cheaper. So that's for perfect substitutes. And now we can come to perfect complements. So perfect complements usually have an indifference curve that is just similar to the actual outline of the graph. And so what this is saying is, at this particular point, you are consuming a certain amount of good X and a certain amount of good Y. So you're consuming, since they're complementary goods and consumed together, you're consuming some of each of them. Now, if the price of good X were to go down, that would mean you would consume more X, and you would move somewhere along this line. Now, this wouldn't be feasible just because they're complementary goods. We're talking about something on the lines of a left shoe and a right shoe. And so, if you have just one left shoe, and you have 4 right shoes, that really doesn't go together, these extra 3 shoes don't really do anything for you, because the left shoe and right shoe are consumed together. And so the only way that they can increase is in this direction, so if you have one more of each of them. And that's why this sort of curve is made like a right angle, or it's on a right angle, or it's just similar to the outline of the graph, just saying that the only way you can increase or you can go to a position of high utility is if you move in this direction, or you consume more of both goods rather than just more of one. And so that's why, let's just go through the options so that we know which is the correct answer. And so it says, except for perfect substitutes or complements, an indifference curve has a negative slope and becomes flatter as we move to the right. And so that seems to be our correct answer, which is A, just because it said both things. First of all, we have a negative slope, and secondly, the slope is getting flatter and flatter as we move to the right, where we increase consumption of good X. The next one says, an indifference curve has a negative slope, but becomes steeper as we move to the right. And so that's incorrect, just because you can see this is much steeper or much higher in slope value, just because slope is usually rise over run, and so there's a huge segment over here to go with your rise, and there's a very small run segment over here, and so that's why the slope over here is going to be much larger than over there, and so we can put a run over here just so that you know that. So that's why the slope is getting consistently flatter as we move to the right. The next part says an indifference curve has a positive slope. Now that one goes right out of the window, just because we know that curves like this always have negative slope, just because to increase one good you have to give up some of the other good. And that's basically talking about the negative trade-off. The last one also starts with positive and says the slope becomes steeper, so they both are incorrect. And hence the answer is A, or an indifference curve has a negative slope and becomes flatter as we move to the right.